Hello everyone, welcome back to the lecture number 5th of week 9. In this lecture, we will going to explore Maclaurin series. In the last lecture, we have seen Taylor series, and in the previous of the last lectures, that means for week 9, we have chosen Taylor series and Maclaurin series, starting with Taylor's theorem and Maclaurin's theorem. We had seen some of the examples where Maclaurin's theorem and Taylor's theorem will help us to solve those problems. In the last lecture, we had seen Taylor series where we have seen that for any function can be approximated by polynomials, some of the polynomials of different orders. And Taylor's theorem was an infinite sum for the terms related to the derivative of the functions. Here in the Maclaurin series, we will see how the Maclaurin series has been derived from the Taylor series. That is, if you remember that one, the Taylor series was about some point, right? So, A will be the fixed point, and we had defined NA as a neighborhood of that point, and then we want any function in that neighborhood fx, and this can be directly approximated by f a x minus a into f dash of a, the derivative of that function at that point, right, and so on. So, it is an infinite thing, and if I put a equal to 0, this will become a Maclaurin series. So, Maclaurin series is nothing but f of x can be written as f0 plus x into f dash of 0 plus x square by factorial 2 f double dash of 0 plus x cube by factorial 3 f triple dash 0 plus of f4 x4 by factorial 4 f4 0, right, and so on. So, that's the sum of the infinite derivatives you can choose. So, and it can be written as fx equal to sigma n equal to 0 to infinity fn 0 by factorial n x by power n. So, Maclaurin series formula is used to find the value of any function around the point origin x equal to 0. Now, we will look some problems where Maclaurin series will help us to write as a sum of its derivative and sum of the infinite terms. So, function is going to be written as infinite terms, summation of those infinite terms, and it will be only help when we use the Maclaurin series formula. So, here find the Maclaurin series expansion for a function e to the power x, exponential x. So, it is an important one, and we can find out, to find out this, we have to firstly find out first derivative, and we knew that this first derivative is the same one, then the second derivative, it is the same one. So, any derivative of this function is the same one, right. So, now we have to choose f of 0. So, f of 0 is equal to e to the power 0, this is equal to 1, f dash of 0 is equal to e to the power 0 is equal to 1, and so on. So, each derivative of this at the point 0 is equal to 1, each derivative at the point 0 is equal to 1. So, using the Maclaurin series formula directly, fx can be written as f0 plus x f dash of 0 x square by factorial 2 f double dash of 0 plus x cube by factorial 3 f triple dash 0, and so on. So, here putting the value 1, and this is going to be x into 1 plus x square by factorial 2 into 1 plus of x cube by factorial 3 into 1 plus of x4 divided by factorial 4 into 1, and so on, right. So, using this one, you will get Ex exponential x equal to 1 plus of x by factorial 1 plus x square by factorial 2 plus x cube by factorial 3 plus x4 by factorial 4 plus so on, right. So, this is the, in the right hand side, as you can see, this is the infinite terms containing from the constant function to x, the first order, then second order, the third order, the fourth order, and so on. So, you can see here, this is the constant function This is the first order, this is the second order, third order and fourth order and so on, right. So it's a sum of the polynomials of different orders that's equal to only one function, that is fx. So fx can be written as summation, that means infinite sum of the different orders of the polynomials. Similarly, can we find e p power x, right? We had seen e p power x equal to 1 plus of x plus of x square y factorial 2 plus of x cube y factorial 3 plus so on. Now we are looking for, or we are interested in finding out the Maclaurin series expansion of a function a p power x. So let function a p power x is given and we have to find out the different derivatives. So first derivative of a p power x, f of x equal to a p power x. So f dash of x is nothing but a p power x into ln a. We have done this one, right? And similarly, how we have done this? Have you remembered it? So y equal to a p power x, take the logarithm both side. So this will become x to power ln a and this will become how much? 1 by y dy by dx is equal to ln a, right. So dy by dx is nothing y into ln a. So y is equal to how much? A p power x into ln a. That was the rules where we find out the first derivative a p power x. Similarly, the second derivative will be quite easy, as ln a is a constant and a p power x, you know the answer. So that means a p power x into ln a into ln a, right. So ln a ka whole square, and similarly you can find out the different derivatives so on. So f double dash of x, f triple dash of x and so on. So now put the value here, find out f of 0. F of 0 is a p power 0 is equal to 1. F dash of 0, that is equal to a p power 0 into ln a. So this is equal to 1 into ln a. So this is equal to ln a. F double dash of 0 is equal to a p power 0 into ln a ka whole square. So this is equal to ln a ka whole square and so on, right. Putting all these values here, the right hand side, you will get a p power x can be approximated using the Maclaurin series expansion as 1 plus ln a into x plus of ln a ka whole square by factorial 2x square. So that means a p power x can be written as 1 plus of x by factorial 1 into ln a plus of x square by factorial 2 ln a ka whole square plus x cube by factorial 3 ln a ka whole cube and plus so on, right. So that is the quite easy things to do this, and we had seen this one for Maclaurin series. So in the left hand side you can see that this is a function a p power x, and in the right hand side it's an infinite term, sum of the infinite terms containing different order of the polynomials. Similarly, can we find the Maclaurin series expansion of log 1 plus x? Log 1 plus x can be written as fx equal to log 1 plus x, and then we can find out f dash of x equal to 1 divided by 1 plus x. Similarly, f double dash of x minus 1 divided by 1 plus x ka square, and f triple dash 2 divided by 1 plus x ka whole cube. f4 is equal to minus 2 cross 3 divided by 1 plus x to the power 4. So the striking thing is, as you can see here, how much the derivative order is, the 1 plus x and power is the same one, right. So here f fourth, that is equal to 4th, f2 is equal to 2 and so on, right. So according to the Maclaurin series, fx now can be written as f0 into x into f dash 0 x square by factorial 2 f double dash of 0 x cube by factorial 3 f triple dash 0 and so on, and putting the value, finding out the value f0. So f0 is equal to log of 1 plus 0, that is equal to log 1. Log 1 is going to be 0. Similarly, f dash of 0, 1 plus x, that is equal to 1. F double dash of 0, that is equal to minus 1 plus 0 ka whole square, as you can see here, right. and f triple. So, f dash of 0 is equal to 1, f double dash of 0 is equal to minus 1 divided by 1, f triple dash of 0 is equal to 2, and f fourth of 0 is equal to minus 6, right. So, in this order, and f of 0 is equal to log of 1, that is equal to 0. So, starting with 0, 1, minus 1, 2, minus 6 and so. So, now you can see the value, that is log of 1 plus x can be written as x here, f of 0, right. So, that is equal to 0. So, the first term is 1, and so this will become 0, this will become 1, this will become minus 1, this will become 2, right. This will become 2, and another one becomes minus 6, another one becomes something different, right. So, log of 1x is equal to 0 plus of x plus x square by this and so on. So, it will become x minus of x square by 2 plus of x cube by 3, right, since 2 was there, and minus x power 4 and so on. So, now you can easily remember this one using the Maclaurin series. So, log of 1x 1 plus x can be written as in a infinite sum of the different orders of the polynomials. Similarly, look at the fourth question, where it has been asked that find the Maclaurin series expansion of 1 plus x to the power m. The previous question was for log of 1 plus of x. So, function was log of 1 plus x. Here the question has been changed and it has been asked for 1 plus of x to the power m, right. So, obviously find out f of x and f of 0. So, f of 0 is equal to 1 plus 0 to the power m. So, depending on m values, we can find out the value. F dash of x is equal to m into 1 plus x m minus 1. F double dash of x is equal to m into m minus 1 1 plus x m minus 2. F triple dash of x can be find out m into m minus 1. So, it's look like we are going to have some different type of the factorial form, and then we will have the solution or the power of the 1 plus x in terms of m and m minus 1, m minus 2, m minus 3, m minus 4 and so on. So, what is the Maclaurin series? Maclaurin series formula is this one. Fx can be written as f0 plus x into f dash 0 plus x square by factorial 2 f double dash 0 plus x cube by factorial 3 f triple dash 0 and so on, right. So, put the value here in f dash of x, f double dash and f triple dash and f fourth one. So, f0 is 1 plus 0 power m. So, 1 to power m, and taking m as a positive, that will give you 1, right. F dash of 0 is equal to f dash of 0, as you can see here, m into 1 plus x m minus 1, putting the value in place of x as 0. So, this will give you m. Similarly, f double dash m into m minus 1 into 1 plus x to the power m minus 2, that will give you the constant. So, as you can see here, only the constant will play a vital role. So, this constant, this constant, this constant factor of the derivative. So, what we are looking for? We are looking for in a derivative of the function, either it is the first derivative, second derivative, third and fourth and so on. We are looking for its constant coefficients. Why? Because Maclaurin series says that when x equal to 0, it will be the expansion of that terms. So, that is why putting the x equal to 0 will become 1 plus x to the power anything m minus 1, which is positive. So, 1 plus 0 to the power positive something. So, this will be 1. So, we are looking for only the constant terms or constant coefficients of each term for the derivative of the 1 plus x to the power m. That's the idea. So, as you can see here, the what will be the constant coefficients? The constant coefficient is m into m minus 1, m minus 2 and so on. So, now after putting all these value in Maclaurin's formula here, right, f0 will become how much? See here, f0 is equal to 1. So, 1 x into f dash of 0, f dash of 0 is equal to what? M x square by factorial to f double dash of 0, f double dash of 0 is equal to m into m minus 1, f triple dash 0 is equal to m into m minus 1 into m minus 2 and so on. So, 1 plus x to the power n, simplify the whole expressions and this will comes out 1 into mx, m into m minus 1 by factorial 2x square, m into m minus 1, m minus 2 by factorial 3x cube and so on, right. So, in a simple way we can define this one as 1 plus x to the power m is nothing but this is 1 plus of m into x by factorial 1 plus of m into m minus 1 into x square by factorial 2 plus of m into m minus 1 into m minus 2 into x cube by factorial 3 and plus so on, right. So, that is quite easy to do this. Now, look at for expansion of 1 minus x to the power m. In the previous questions, we have find out the Maclaurin series expansion of 1 plus x to the power m. Here, we have to find out the Maclaurin series expansion of 1 minus x to the power m. So, doing the same thing, fx equal to 1 minus of x to the power m and henceforth f dash of x is equal to nothing but minus m into 1 minus x to the power m minus 1, f double dash of is equal to minus in m into minus m minus 1. So, this will comes out to be m into m minus 1 into 1 minus x to the power m minus 2, f triple dash of x is equal to m in minus of m into m minus 1 into m minus 2 into 1 minus of x to the power m minus 3 and so on. We will see. So, here using the Maclaurin series expansion, you will see here fx equal to f0 plus x into f dash of 0 plus x square by factorial 2 f double dash of 0 plus x cube by factorial 3 f triple dash of 0 and plus so on, right. Put all these values. So, firstly find out f0, f0 is equal to 1, f dash of 0, f dash of 0 is given here, you have written here. So, how much the value? Put the value here 1 minus 0 m minus 1. So, this will comes out to be minus m, f double dash of 0. So, look for the constant coefficient. So, this is equal to m into m minus 1 and f triple dash of 0 is equal to minus m into m minus 1 into m minus 2 and so on, right. Put all these values here, that will be your answer. So, putting the value 1 minus of mx plus of m into m minus 1 x square by factorial 2 minus of factorial 3 and so on, right. So, 1 minus of x to the power m and firstly we have to write down 1 plus of x to the power m and this can be written as 1 plus of m into x by factorial 1 plus of m into m minus 1 x square by factorial 2 plus of m into m minus 1 into m minus 2 x cube by factorial 3 and so on, right. And 1 minus x to the power m. So, just change the alternate sign. So, we are starting from the positive 1 minus m into x by factorial 1 plus of m into m minus 1 x square by factorial 2 minus m into m minus 1 into m minus 2 into x cube by factorial 3 and plus so on. So, that will be the Maclaurin series expansion for 1 minus x to the power m. Now, look at if we put m equal to minus 1, what happened? We had find out 1 plus x and 1 minus x when m equal to m is greater than 0. So, positive constants. What happened when I put a particular case when m equal to -1? Look at the structure and then we will find out using the Maclaurin series expansion formula. So, fx is given, fx is equal to 1 plus x to the power -1. So, f dash of x is equal to -1 into 1 plus x to the power -2, f double dash of x is equal to 2 into 1 plus x minus cube, f triple dash is equal to -2 into 3, 1 plus x to the power -4 and so on, right. Now, find out the value. Firstly, f0 is equal to how much? This is equal to 1 to the power -1. So, this will become 1. F dash of 0 is equal to, so this will become -1, right. F double dash of 0 is equal to 2. F triple dash of 0 is equal to -6. F fourth one of 0 is equal to 24, right, and so on. So, put all these values here, and this will gives you 1 minus x plus x square minus x cube plus x4 minus and so on, right. So, 1 plus of x minus 1 can be expanded and approximated using the Maclaurin series, and this is equal to 1 minus x plus of x square by x square minus x cube plus x4 minus x5 plus x6 and so on, right. Similarly, we can have the Maclaurin series expansion of 1 plus x to the power -2, 1 plus x to the power -2. So, we had fx equal to 1 plus x to the power -2, then f dash of x can be written as -2 into 1 plus x minus cube, f double dash and f triple dash. One can easily find out the derivative of 1 plus x to the power -2 and then use the Maclaurin series formula. The Maclaurin series formula says that fx can be approximated with the value of the function at 0 and its derivative at that point 0, right. So, f0 plus of x into f dash 0 plus x square by factorial 2, f double dash of 0, x cube by factorial 3, f triple dash of 0, x4 by factorial 4, f fourth of 0 and so on. So, using that one, you will see the answer 1 plus x to the power -2 can be written as 1 minus 2x plus of 3x square minus 4x cube plus 5x4 and so on, right. In the previously you had seen that 1 plus x to the power -1 have the coefficient as 1 only. Each term have the coefficient either 1 or -1 if you are taking a whole sign as a positive, but that means 1 minus x plus of x square minus x cube plus x4 and so on, right. But as you can change m equal to -2, this will be going to be, the coefficient is going to be changed 1 minus 2x plus 3x square minus 4x cube plus 5x4 and so on, right. So, it is quite easy and very interesting series whenever you are. So, can I give you assignments? So, just take this one as your assignment, that find Maclaurin series expansion of 1 plus of x to the power minus q and 1 plus of x to the power -5. What will be your answer? So, look at the structure. If you are going through it, it will going to be in a patterned way. So, as we have taken this 2, this will gives you 1, 2, 3, 4, 5. If you are taking as a -3, it will give you another pattern. If you are taking as a -5, it will give you the another pattern. So, it will be very interesting if you are just to find out the Maclaurin series of these problems. And I believe that this will be a good concept for the Maclaurin series expansion and any expansion of a given function. So, if somebody are going to use the trigonometrical expansion like sin x, cos x, tan x, around the x equal to 0, you will use the Maclaurin series expansion and you will get the solution quite easily. So thank you so much, and this will be the end of the week 9. We will go with week 10, where we are seeing the maxima and minima now. So thank you so much.